Okay. We're starting off with our 7.2 Explore. All right. So it's asking us to graph this quadrilateral. You can see that there's a grid here. So we're going to graph this quadrilateral. It says over 1, up 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to make that A. Okay. Over 7. 1, 2, 3, 4, 5, 6, 7. Then up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to label that B. Over 7, up 7. So this was 7. So 1, 2, 3, 4, 5, 6, 7. We're going to label that guy C. And then over 1, up 7. And we're going to label that guy D. Then we're just going to connect it. Okay. What type of quadrilateral is the figure above? Well, what type of quadrilateral is that? Quadrilateral just means four-sided shape. Rectangle. It says slide the quadrilateral ABCD 4 units to the right and 6 units down. So all this is saying is take this every point, 4 units to the right, 6 units down. So they have their table for your Explorer. 4 units right. So 1, 2, 3, 4. Then what did it tell me to do? 1, 2, 3, 4, 5, 6. And now they're telling me to label this what? That was A, so what am I going to label it? A, what do we call that? Prime. So I'm now going to do that to B. Over 1, 2, 3, 4. Then it said go down 6. 1, 2, 3, 4, 5, 6. I want you guys to try C and D. All right. C over 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. And D, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Did yours look like mine? Yeah? Okay. What are the coordinates of the new quadrilateral? So we're going to list A's first. A prime is over 1, 2, 3, 4, 5. Up 1, 2, 3, 4, 5. B is over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And up 1, 2, 3, 4, 5. C is over 11, up 1. And D, we went over 5 and up 1. All right, so here's what we're going to do. I want you to look at just the x values. The x values are listed first. So we're going to look at the x values up here and the x values down here. How did I get from 1 to 5? Not a trick question. How did I get from 1 to 5? How did I get from 1 to 5? Yes, Letty. I went up 4. I added 4. How did I get from 7 to 11? What? Add 4. How did I get from 7 to 11? Plus 4. How did I get from 1 to 5? Okay, now we're going to look at the y coordinates. How did I get from 11 to 5? What? Over? If I go from 11 to 5, I like your 6. Down, I subtracted. So 11 to 5, I'm subtracting 6. 7 to 1, does it still work? Okay, before we flip to the next page, read this step again. Just read it silently to yourself. Any idea where we would have got the 4 and the 6? We said we added 4 and we subtracted 6. Any idea where we got that? What did it tell me to do right here? It told me to go to the right 4, and it told me to go down 6. So we can associate the word down with subtraction. So if we go down, it's subtracting. If we go right, what did we do? Did we add or subtract? If we move to the right, did I add or subtract? Add. All right, I'm going to flip it over. How do the side lengths of triangle A or rectangle A, B, C, D compare to the side lengths of A prime, B prime, C prime, D prime? So I want you to write down the side lengths here. How long's this one? 1, 2, 3, 4, 5, 6. I want you to go around this entire triangle or rectangle and write the side lengths. I want you to go around this entire rectangle and write the side lengths. All right. What was the length here?
4,
Here?
6,
Here?
4,
Here?
6, 4, 6, 4.
So how do the side lengths compare?
They're the same.
They're the same. What's another word we could use for same?
Congruent.
Congruent. Okay. Now it's saying, how do the angle measures of A, B, C, D compare to angle measures A prime, B prime, C prime, D prime? Well, let's look at this. All of these are what angles? Right, so they all measure 90 degrees. Is that the same thing down here? Do all these measure 90? So what can we say about all the angle measures? They are what? They are either congruent or the same. I want you to answer this one. Are A, B, C, D, and A prime, B prime, C prime, D prime similar or congruent? Explain why you think that. You tell me whether you think they're similar or congruent. Who thinks they have a really good answer for me of whether they think it's similar or congruent? Nobody thinks they can tell me if it's similar or congruent? All right, first tell me just if you think it's similar or congruent. Don't have to give me a reason why yet. Do you think it's similar or congruent? Why? You're right. Why? You're exactly right. Congruent. What did we just prove? Are the side lengths the same? Are the angles the same? Is this the exact same shape, just in a different spot? That's why it's congruent. I just moved it. It's the same size and same shape. You could have said something like, the angles and side lengths are the same. Okay, so what we're looking at today is a translation. When points or figures are shifted right, left, up, or down, the transformation is called a translation. Do you think all translations create congruent figures? What do you think? Do you think they will always create a congruent figure? Write down what you think. Do you think they will or will not? Yes or no? I kind of figured.
The other end?
All right. This was not really meant to be a trick, but it kind of is. If I'm only ever shifting the figure right and left or up and down, am I ever going to change its size? If I'm just moving it right, left, or up, down. So if I never change its size, is it always going to be congruent? Yeah. It's never changing size or shape, it's just changing position. Okay? Okay. Go ahead and put this in your binder. I handed out the set of notes that we're going to be taking. Go ahead and get those out. All right, so this is CO2. I can translate an image on a coordinate plane. What does the standard XY coordinate plane mean? On the graph. Where are we going to see that? Where are we going to see that verbiage? On the what? ISASS. All right. Vocabulary, real short today. Translation, a transformation in which a figure is shifted up, down, left, or right. So it's just, so here's our pre-image, our original one. Shift over and up. Did the pizza change? Same pizza, isn't it? So that means they are congruent. Now remember when we do this too, if this were labeled A, B, C, this needs to be labeled A prime, B prime, C prime. Okay. All right, here we go. A triangle with coordinates R, which is 2 and 5, S, 0, 1, and T, 3, negative 1, is translated 2 units right and 3 units down. Okay, so we're going to do that. 2 units right. I'm going to just start with R. 2 units right, 1, 2. And then it said down 3 units, 1, 2, 3. So here's my new R, and I'm going to label that R prime. All right, I'm going to do that to S. Over 1, 2, down 1, 2, 3. And T over 1, 2, down 1, 2, 3. We're going to write the coordinates. R's new coordinate, it's always over first, so over 4, up 2. S over 2, but now I'm down to negative 2. T over to 5, down 4. Okay, both of them. Okay. All right, so now what we're going to look at. Bye, Wyatt. Okay, now what we're going to look at, just like we did before, how did I get from 2 to 4? How did I get from 2 to 4?
Added 2.
Thank you. Whew. How did I get from 0 to 2?
Subtracted 2.
From 0 to 2?
Oh, added 2.
Added 2. From 3 to 5? Added 2. So all my x values, I added 2. This is what's going to be known as your rule. All your x values, you added 2. Okay, now let's look at our y values. How did I get from 5 to 2? What about 3? Did I add or subtract 3? Subtract. How did I get from 1 to negative 2? Subtract 3. How did I get from negative 1 to negative 4? Negative 1 down to negative 4. How did I get there? What's been the pattern the whole time? Subtract 3. So all my y values, I've subtracted 3. There's my rule. And we get that from right here. If it says go right, it's going to be an addition. Add 2. If it says go down, we figured out it's going to be subtract. Okay. All right, here we go. A triangle with the coordinates negative 4, 2, 3, 0, and 1, negative 1. All right, so let's first graph that. Over to negative 4, 1, 2, 3, 4, up 2, 1, 2. That is M. N is over 3, up 0. And P is over 1, down 1. Ooh, that's a tiny triangle. Okay, now it's saying it's translated 3 units to the left, 1 unit up. So let's we'll start with M. I go to the left, 1, 2, 1, 2, 3, up 1. There's my new M. Okay, now my N. I'm going to go over 3. 1, 2, 3, up 1. That's my new N prime. And finally P. 1, 2, 3, up 1. Is it okay that they overlap? Yeah. So I'm going to write my new coordinates. M prime is now over 1, 2, 3, 4, 5, 6, 7. And it's up 1, 2, 3. n prime. We didn't go over any, but I'm up 1 now. P prime. I went over to negative 2, but I didn't go up any. So there's my new coordinates. So let's look. How did I get from negative 4 to negative 7? How did I get from negative 4 to negative 7? Not a trick question. Minus 3. How did I get from 3 to 0? Minus 3. How did I get from 1 to negative 2? So all my x values I minused 3. Now let's look at my y values. How did I get from 2 to 3? Plus 1. How did I get from 0 to 1? Plus 1. Negative 1 to 0. Plus 1. So all my y values, I added 1. So notice here, this was left. When we moved left, what happened? Did I add or subtract? Subtract. And here I went up. When I went up, did I add or subtract? Add. So when we go right, we're adding. When we go down, we're subtracting. When we go left, we're subtracting. When we go up, we're adding. Makes sense though. Down and up go together. So down is subtracting, up is adding, right is adding, left is subtracting. All right, let's go ahead and go to the next page. This is just telling us the rules. Just what we figured out. If it's right, it's adding. If it's left, it's subtracting. This is your x values. Your y values, if it goes up, you're adding. If it goes down, you're subtracting. I would make sure I have that written down. Okay, so now let's take a look at our rules, okay? Here we go. Describe the horizontal and vertical path described by each transformation. So it was this. Now I'm adding 1 and I'm adding 4. So just look at the x. If I'm adding, am I going right or left? Right. I'm going right, 1, and if I'm adding to the y, am I going up or down? Up 4. That's why we wrote this down right here. This is going to be important. All right, this one here. Since I'm subtracting 2, what's happening? Am I going right or left? Left. Is anything happening to the y? So is the y moving up or down? No. All right, you guys describe to me what's happening in A and B. Okay, who can describe to me what's happening in A? Am I going right or left?
Left.
Left. How many?
4.
And am I going up or down?
Down.
Down.
5.
Anything happening to X here? So can I just say X stays the same? What's happening to Y?
Up 3.
Do we understand how to read the rules? Does that make sense? Okay, we're almost done, guys. Okay. Here we go. A transformation rule. Right here. Here's our transformation rule. Is applied to this triangle. What are the new coordinates? So D prime. It says to add 6 to the X already. So if I'm at -5 and I add back 6, where would I be? +1. Very good. What's it telling me to do to the Y coordinate? What's it telling me to do to that Y coordinate? So if I have 2 and I -1, I'm at? Same thing. If I'm at -2 and I add 6, where am I? 4. If I'm at 2 and I take away 1, where am I? All right, B, it says add 6 to my X. I'm at -2. I got to add 6, I'd be where? And I'm at 4, and I need to take away 1, where would I be? So these are my new coordinates. All right, your turn. I put a graph there just in case you needed it. It says a transformation rule of X minus 2, Y plus 7 is applied to the triangle formed by the points P, I, G. Graph, pig, and then pig prime. I want to know the new coordinates. So P, that's a P, I wrote an A, I, G. I want to know all the new coordinates. says graph them too, yeah. On the checkup, you will have to graph and give me the new coordinates. I'm telling you that right now. You're going to have to do both.
Two shapes is the graph has. You need to-
Okay, I've only got about 4 minutes. So I'm going to graph this first one. Over 3, down 4. P. Over 0, 0, I. Negative 1, negative 7, G. Now, I don't care if you're like, oh man, I know I gotta go, that's left. So I'm gonna go left, and you graph it all first, or you write the coordinates first. I'm not gonna know which one you did first, okay? If you want to, you can do the coordinates first. So x is minus 2, so that's gotta be, let's see, minus 2, that'd be 1. And this would be 3. I, negative 2, 7. And then that would be negative 3, 0. If you put all those first, that's fine. If you do this, left 2. So I go over with P, over 1, 2. And then it says up 7. 1, 2, 3, 4, 5, 6, 7. I don't care if you do that first and then write your new coordinates. So that gives me negative 2, 7. And then I would go over 1, 2, up 1, 2, 3, 4, 5, 6, 7. Oops, I don't want to write 7, Ashley. Good gravy. Are these shapes similar or congruent? Congruent because they're just in a new spot. Same shape, new spot. All right, you may put